goes into some more detail about how testing works in the Ruby world, and also covers the updates to the Cucumber Chef tool, which was released, the version 2 was released just over a month ago. So it covers a bunch of that kind of stuff, and is really much more definitive discussion around how you do testing with Chef.
Why do you think there's so few books on Chef? You seem to be having a fairly lonely furrow. It'd be nice to see a bigger ecosystem, a cookbook and a practitioner's guide and those sort of things. Why aren't more authors interested in writing books on Chef?
So the question is, why are there not more books about Chef? I think it's because the wiki is so good. There is an enormous amount of content, and effort goes into maintaining the wiki. The wiki really is a superb resource, but there is call for a canonical tome, which I'm working on writing, and that will be updated and maintained, and it will be to an extent slightly independent of Opscode. But the wiki is great. It's not a wikis sometimes are just a bit rubbish, but the Opscode wiki is really very, very good. A lot of time goes into it. There are people whose job it is to maintain that. There is a technical writer who is specifically employed by Opscode to make sure the quality of the documentation is good. So the wiki is very good.
I mean, it is very good, but there's no narrative. As a learning curve is not the best way of learning.
Sure.
It's nice when an author takes you through a structured exploration of the topic.
And that is what I'm endeavouring to do. Yes?
It seems to me that there are two different mechanisms to configure a machine, a server. The first one is to get the service that you want, and then the second is to populate with peculiar data this service. For example, the SSIG demo. I guess that you can get a package for I don't know, Ubuntu 12, and then you have the search mechanism to populate, for example, the port 2022, right? Then my question is everything processed on the Chef server, and then how does the client get this information?
Okay, so the question is, if you're defining a service and its configuration, or possibly building up a system using search, is the heavy lifting done on the Chef server and then somehow transported to the client, or what? How does the system work? The system works, and this is a very important principle, there is no heavy lifting done on the Chef server. The Chef server is just a publishing platform and a search index, and nothing else. That's all it is. It's an API in front of a publishing platform and an index. All the node does is gets the information, so the recipes, the data which is in the search index, pulls it down onto the local machine where Ruby is evaluated on the local machine and the configuration is built in real time. So all the calculation, all the building up of the configuration is done on the node. No calculation, no processes running on the server.
So one more question. So, for example, you have a database with all your data, then the Chef server that gets the data from the database, and then provides this data to the client.
I'm not sure I understood that question. So there's another question, so I'll come back to you. Yes?
It was just really, you talked about a bare metal restore. I was wondering, so in that case, you just want to have your operating system and your Chef client on the machine.
Yeah. So the question is, in the case of a bare metal restore, how do you go about that? Is it just the bare metal plus the Chef client? And I think the answer to that is yes. So the simplest way that you could do this, and if this has aroused sufficient interest, I'll come back and we'll do a hands-on lab. We'll maybe get a few machines together and we'll build some infrastructure using Chef, and I'll show you how it works. But broadly speaking, Chef has the capacity to reach out into various clouds or speak to a machine that you've already set up and kick-started, and it's got log-on capabilities and admin ability. And all you need to do is get the Chef client on the box. Once you've got the Chef client on the box, and assuming the box is on the network, and speak to the Chef server, then all you need to do is run the Chef client, and everything else is taken care of. So what that means is, if you want to do your images, and here I would say images are very valuable, by all means have your image which has got the Chef client already installed on it. That's fine, easy. Give me a machine with Chef client on, and actually maybe even have as part of your recipe or your profile, as soon as the system is finished building, run Chef client. So you could actually put that in your jumpstart mechanism or your AI mechanism, such that the whole system comes up and is configured in one go.
Okay, so could you say DHCP to build a system, then
Exactly so.
the Chef client pick everything else up, and then remove, and it'd be the box.
Yeah. Alistair.
The more powerful you make a tool, the more dangerous it is. So, do you have any experiences of things going horribly wrong with Chef, where people have sort of made mistakes in their recipes and it's been rolled out platform-wide and sort of taken everything out? Or are there any mechanisms to kind of prevent that?
I think there certainly have been occasions with people who've come onto the IRC channel and said, I've changed some system, some config file across my systems, and now I can't SSH to any of my machines, help me, or some other such thing. And yes, you're right. With great power comes great responsibility. And this is why I think test-driven stuff is so valuable. Because if you build into your process something which says, this is the way the system should behave, and that includes it should fundamentally be doing the job it's supposed to do, if we then have a test environment over here, and we run our tests against it, and the tests all pass, then we can be confident that the system will go ahead and work. And this is absolutely standard in the world of deploying code. You would use Jenkins, for example, and you'd say that you can only deploy if the build is green. If the build is green, that means that the tests are passing. Assuming that we've got adequate test coverage, we can be confident that if the tests are passing, we can go ahead and deploy the code. It's no different from Chef. If you put in place a series of checks and boundaries so that we can say, is the system behaving as well as it should to the best of our ability, notwithstanding the quality of our tests? If the tests are green, push the button and go ahead and roll out. It's no different from rolling out code.
Building on top of that, despite the tests, you might have a very large infrastructure, and you might have a base recipe or cookbooks, as you were showing. And for example, how do you suggest you would deploy a change to a base cookbook to your infrastructure in a staggered way? Because I mean, what we're doing is we put the specific version of the cookbook that we want to deploy in the base node definition, and then when you upload that, that's going to hit all your boxes at the same, well, at the interval wherever you're running the Chef client. So what's the good best practice to do that in a way that...
So I think the question is, suppose we have a role, a base role, which contains some stuff which is shared across a wide number of machines across the infrastructure, and we want to deploy a fairly substantial change to that base role. How would we go about deploying that in a staggered way, such that, and I'm not sure what the reason for this is, but such that the machines aren't all changed at once? Is this because you don't want them to all change at once, or because you don't want contention on the Chef server? Or
the company you're working for, it's not happy with changing 10,000 servers at the same time, despite all your tests. Maybe it's your approach, you just don't want to do that.
Okay, that's a really interesting question. So the use case which has come up is, suppose you've got 10,000 machines that you want to make a change to, and the policy says you can't make a change across 10,000 servers at once, but you do want to make changes to the base recipe. How would you go about implementing that change across 10,000 machines in a staggered way? I can think of a couple of ways that we could do that, but that's probably getting to be specifically fairly niche for this broader conversation. So let's talk about that over coffee in a second. Alistair had a question.
Yeah, so talking about the test-driven stuff, I suppose if you've done everything properly you could actually, in a cloud, it's the ideal environment for this, you could deploy all the existing infrastructure you've got, but using smaller instances. And on a cloud, obviously, you've got hourly billing, and then presumably you could deploy the code and then run through all your tests. I mean, that's obviously quite powerful. Do you have people actually doing that, deploying smaller versions of their entire infrastructure for test purposes?
So the question is, Alistair is saying the idea of being able to use the cloud to build a very small mini version of your infrastructure to run all of your tests and then switch it off again, do people actually do that? The answer is yes. And in fact, Cucumber Chef is designed specifically to do that. Cucumber Chef does that using Linux containers on AWS, but it will be expanded to support other clouds and other virtualization mechanisms. But yes, there are people who are doing exactly that kind of thing. They're standing up a test environment, running their tests, saying, okay, I'm happy with that, switching it off again, and that can all be done via knife. It can all be done via a command line, or it can be done by a plugin into Jenkins, so that it's just built into your pipeline. And what that means is, we are very, very close to the idea of continuous delivery, or continuous deployment for infrastructure code, which is very exciting. Wow, lots of questions. Chap over here with the specs.
Thanks. How does Chef differentiate which server needs to have a web role or which server needs to have a database role applied to it?
So the question is, how does Chef differentiate whether a node should get a web role or whether a node should get a database role? The answer is the run list. So every node that we have has representation on the Chef server. So the Chef node is an object which lives in the Chef system. And that node has an attribute called a run list. And that run list will have the list of stuff that you want on it. So we might say that our first machine just has the base role and nothing else. And so when the node runs, it will have some unique identifiers such as its host name. It will go to the Chef server and it will say, hello, my name is server123. What's my run list? The run list will come down and various other bits and pieces will look at the run list. And actually this calculation is done on the Chef server because there's some dependencies that need to be solved in a complicated environment. You might say, well, which cookbooks do need to be pushed to the edge so that they can be downloaded? And then those cookbooks are downloaded and evaluated on the local machine.
So in situations where we were talking about with cloud before, where you don't know the MAC address, you don't know the IP address or the host name or anything like that, you were looking at using the dynamic DNS solution for deciding what that box is. And then again, how do you decide within DNS as to what that box is?
So when you bootstrap a machine, so the question is, so in an environment, a cloudy environment, where you don't know the name of the machine or any other such thing, how do you get this unique piece of information into the Chef server without having to use something like dynamic DNS? Well, when you use the bootstrap mechanism, so when you bootstrap a Chef node, what actually happens is that the machine speaks to the Chef server for the very first time. It says, hello, I'm a new machine, I am called, here's my host name, I would like to work with you, please. And then there's a security mechanism which makes that something which is repeatable and not replayable. And now that machine is registered, and so it's actually the client which initiates registration.
But you won't necessarily, though, know the host name either.
Well, you don't need to, because we're not thinking at the level of servers, we're thinking at the levels of application infrastructure. So all we're saying is, hands up, who's a web server? Okay, me, right, do this. Or if you wanted to be more specific, find me all the web servers running Solaris 9 in the interaction data center. Or find me all the machines that are still running SSH on port 22. Find me all the MySQL servers that are still running MySQL 4.
So you still need a golden image, just a very simple one.
You don't need a golden image because you could just deploy a completely vanilla machine. I could have the shipped out of the box SysID CFG and the various other bits and pieces of a very, very standard. Why am I playing this side? You could have the absolute vanilla jumpstart of a Solaris 10 machine, which isn't a golden image, it's just the basic install, and then I can run from my workstation, knife, bootstrap this machine, and that machine will then speak
I'm
to
thinking elastic
Dan-
load balancing. The machine is fired up for you on demand in